Okay, well, we're back for another episode. Anyway, what I forgot to mention last time, a couple things. Here's the gyroscope. Okay, another thing I would change would be the this other capacitor. I would double it up, just like it is here. There's no shunts or anything on it. Obviously, it's a FOC, so everything is done by software instead of hardware. It's where an FOC is different, so you won't have shunts, you won't have these resistors. But here's where I think the design flaw is the PCB board for the MOSFETs themselves here. First off, you have this battery minus because it comes from directly on the minus side, and it's going across the MOSFETs. Well, this is going to cause signal interference. That's one. The thing that went out on is right here. I don't know if it's the same number, but it's the same type of resistor that went out there. So anyway, is the robustness. So you have all this voltage going into this wire right here, positive and negative, and it's got to go across this board. Well, this board is really thin, just like a regular board. It's really thin, okay, and you're expecting all this voltage to go out of it on such a thin board. It's gonna end up causing more problems in the long run. Not to redo this, to do a different board. Obviously, you can do the same design, but it's going to be the robustness, the thickness of the board, and how thick the lines are. So here on my 3000 watt, this is it's an old one. It's a sine wave. So it relies on some back signal from the EMF, relies on some to read a back voltage to be able to tell where the motor is positioned in with the sensors. It's not sensorless, it is Hall, but it has to tell exactly where the MOSFETs are. So it gives a little bit of a negative signal back through the resistors and the shunts and everything. So here we have all the MOSFETs that are laid out here. So 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 4. Obviously, there's more here than there is here. Okay. Instead of 4, there's 6 per. But this is what I wanted to show you, is the robustness. So we have the MOSFETs that are on a nice, really thick cooling plate, because these are gonna, regulate your spurts. So we're expecting 3000 watts and, so 52 volts, 60 amps continuous through these thin sheets. Now, what I would like to see would be, I know this is solder, but would be something more robust like this. See how thick it is? It gets thicker than the side of a razor blade. Okay, now we'll go to this board, and I can already tell you that it's thinner than the side of this razor blade. So this is I think a design flaw. Right here you have the interference, and then you have super thin MOSFETs that can, the super thin MOSFET board. Yeah, that's just my personal thoughts. on this board. I'm not, saying that it's not a bad controller, because it has gotten me just a little over 1,500 kilometers, about 700 miles. If you were to count before I reset my controller and everything the first time, then probably have about 1,000 miles on this controller itself. This one I have about 1,000 miles, but the only thing that went out on this was, that one's still charged. The only thing that went out on this one is the temp sensor, which is why it's all part. But yeah, so I would definitely, like, stack up this bottom board with a lot thicker voltage collection plate. For one, that's step one. That's what I would do. Obviously, this details a lot of the firmware and hardware version in here with the central processing unit that you have right here. It tells signals everywhere, which way to go, every which way. So that's just my opinion on this controller. I'd like to see that this piece right here redesigned, a little bit more robustness, and this not on the MOSFETs. If you have to, bridge it over the PCB board right here and do some extra shielding, signal shielding, so that it doesn't interfere with all these thin wires that are right here. And of course, these thin wires go up against, so you have that underlying wire that can cause interference, and then you have two phase wires that come out of here. So the phase wires do put out a signal outside of the silicone, unless you have an actual shielded type of wire that can actually cause interference being that close to these other type of wires. I've had that happen on many other e-bikes where I had my bundle of wires, because I had so much extra wires that my throttle wire and my phase wires were too close to each other, and what ended up happening is the signal went through.